Well, it's that time of year. The clouds associated with summertime, towering cumulus, cumulonimbus, those daytime thunderstorms that you can see from miles away. And sometimes they give an eerie look to them that can be mistaken for other things from a distance. Chris Brooks sent this one in, and you can see off in the distance the base of a thunderstorm, but then you've got all this overshooting moisture cloud cover in the upper levels. Pretty interesting look. Here's another view, same storm, different time. And if you just take a glimpse of this, it's like, that kind of looks like a wedge tornado, right? From a distance, it's a little ominous, a little creepy. So how the heck do we get a feature like this that looks like something is descending from the clouds? So let's talk about what it looked like on radar. So this picture was captured at about 7 o'clock, which is where I froze the radar, right here looking off to the north and west. So again, perspective, northwest, you're seeing that overshooting top coming towards where this photo was taken. So what phase of the thunderstorm cycle was this in? Well, it lasted about 2 hours. It was fairly small in size, bottoming out right at about 8 o'clock before it got to Tuscaloosa. So the stages of a thunderstorm can often give different looks to the clouds. So initially, of course, you got your rising air. Get to a certain level, that air cools, it condenses, you get your clouds. Step one. Step two, you've got a lot of rising air. That's your updraft. This is what supports development vertically in the atmosphere. It's what allows these cumulus clouds, cumulonimbus clouds, to extend far up into the atmosphere several thousand feet. This is the mature stage. You've got air coming in. There's your fuel source. You got, of course, your downdraft, your rain, sometimes hail, gusty winds. What I think was being seen here on these pictures was the dissipation stage. So we had all that rising air go up. It hit the top of the atmosphere, an equilibrium level, if you will. So no longer can the air go up. It's forced to move horizontally. In addition to that, our winds aloft were westerly. So all that moisture that went up, hit the top of the cloud, it was fanned out ahead of it. So the base of the thunderstorm was essentially gone. It was narrow, very small, not really existing anymore. But aloft, you had that overshooting top or anvil, and that is what gave a look to those clouds. All through summertime, we can have looks just like these, and they can be fascinating to see as those daily pop-ups unfold.